Okay, ladies and gentlemen, good morning once again. Okay, as I told you, uh, now we are going to see actually study maybe one of the most important uh, section of this chapter. Okay, and why is this important? Because the topic is related rates. So in related rates, all the problems are in word problems. Actually, they are all word problems, and most of the students they fail to solve these questions correctly. I mean, why? Because they don't understand the problem, or they understand the problem, but they don't know where to start, or even they know where to start, but they don't know how to set out their equation. Okay, and that's why I suggest you to practice every problem in this question if possible, so that it really improves your understanding skill and problem solving skill, and also improves your vocabulary and blah, blah, blah. Okay. So before we start this class again, now we have one session in the afternoon. We have one session. All right. And next Monday, you will have midterm exam. Okay, most probably now I'm thinking to give a midterm exam on Monday. So you have 4 days for revision. Okay, so within these 4 days, if you have any questions, anytime you can ask me through Telegram or email, or I don't know. Okay, and also you can actually contact your TAs and you can have discussion. All right. All the questions are from chapter 1 to 3. And most probably your midterm exam will be online test. Okay. That means multiple choice questions. You have to answer the questions, just write only one letter. Okay. You need to solve the question and choose the correct answer and just put one letter. That's it. Okay. And how many questions? I'm thinking to ask about 20 questions. Not so hard, not so easy. Okay. So that's it about midterm exam. So today we will talk about related rates. What is it? In this section, we look at problems that ask for the rates at which some variable changes when it is known how the rate of some other related variable or perhaps several variables change. The problem of finding a rate of change from other known rates of change is called a related rates problem. Okay, here that means that now we can start with this example. Uh, okay, all right. We can start with this example. As you see here in this picture, we have a ladder, right? It's just leaning against the wall. And it says that a 20-meter ladder is leaning against the wall, and the base of the ladder is sliding away at 2 meters per second. To some reason, maybe it is too high, or maybe the ground is slippery, right? Okay. So actually the foot of the ladder is moving away from the foot of the wall. What is it? At the rate of 2 meters per second. Just a minute. I need to read my glasses. Okay. How fast is the top of the ladder sliding down the wall when the base of the ladder is 12 meters from the wall? That is one question, okay, a problem. Usually, it's actually the picture in this here, it's not given. So you need to read the problem well, understand this, if possible, draw a picture or diagram, whatever it is, then try to, start solving the problem. So here are the suggestions how to solve related race problem. Number one, draw a picture and name the variables and constants. That is a general strategy to solve math problems, right? First, because most of the time, if you understand, it's okay. But if you draw the picture, if you're talking about, let's say, distance time speed problem, okay, draw a line segment and label the starting point, the end point, or the starting point and destination. If you're talking about, for example, some kind of parachute, for example, also draw the picture and this kind of stuff, okay? And write down the numerical information, what is given in the question. And also actually it's a kind of math tradition. Write it down, what is given, and after that write down what you are asked to find. Right? Usually, for example, just write everything. After that, x equals question mark. That means that in this problem, we are going to find the value of x. And write an equation that relates the variables you may have to combine two or more equations to get a single equation that relates the variable whose rate you want, the variables whose rates you know. Anyway, differentiate with respect to time, because here a lot of problems are, what is it, dependent on time. And that's why actually t will be independent variables, and others are dependent variables. And after that, evaluate. Use known values to find the unknown rate. Anyway, actually, these are just suggestions. And as you practice more questions, you will actually shape how to solve these kind of problems. So in this question, it says that first draw a picture. The picture is already drawn. The second step is write a numerical information. What is the numerical information? Here, the length of the ladder is 20 meters. 20 meters, right? And suppose that at the beginning, it is X meters away from the foot of the wall, okay? And how fast is the top of the ladder sliding down the wall when the base of the ladder is 12 meters from the wall? And here it says that the base of the ladder is sliding away 2 meters per second, right? So now suppose that at any moment, okay, let's say the foot of the ladder is X meters away from the foot of the ladder. And here also the height of the ladder, right? That is a point of contact, the top of the ladder with the wall. Okay, that is Y meters. So as you see here, since we suppose that the wall is 90 degrees to the ground, so it forms a right angle triangle. So from here, I can write this equation then. Here we have X squared plus Y squared is equal to 20 squared. Simply, that's equal to 400, right? And what is given here? It says that the base of the ladder is sliding away at 2 meters per second, right? Sliding away 2 meters per second. What does it mean? It means that actually here, the distance, right? It is sliding away from 2 meters per second. So here we have dx dt, right? That is equal to 2 meters per second. It is increasing, right? This x is increasing. That's why it is positive here. Okay. So what is the question here? How fast is the top of the ladder? How fast is the top of the ladder sliding down the wall when the base of the ladder is 12 meters from the wall? Right? So what are we going to try to find here? It says how fast the top of the ladder is sliding down the wall. So that means that we are going to find the rate of change of y with respect to t. It says how fast. And when the base of the ladder is 12 meters from the wall, that means that when x, right? X is a distance between the foot of the ladder and the foot of the wall. When x is 12 meters. So that is what we're going to find here. Okay. So actually, I have just written everything given. Now we have to start solving this problem. Okay. So now again here, when t changes, x is changing. That means that x is the function of t. And also y is changing. Also y is a function of t. Okay. So now in the previous actual class, we studied about implicit differentiation, right? So we know how to differentiate these functions. Here, x is a function of t, y is a function of t. Now, if you differentiate both sides, what we have here? Here we have 2 times x times, now differentiate x with respect to t. That is dx dt. Plus, how about y? Here we have 2 times y is a function of t. Here we have dy dt. On the right-hand side, the constant number, if you differentiate with respect to time, it's not changing. The rate of change of this constant number is 0, right? So now from here, we know that dx dt, it is given, right? So it is changing at the constant rate, that is 2. So that is 2 times x times 2 plus 2 times y is equal to dy dt. Now, what is the question here? We need to find, it's not y. So here we have times dy dt. That's equal to 0. Or if you just calculate dy dt from here, dy dt is equal to take 4x to the right-hand side. It is minus 4x. Divide both sides by 2y. So that's equal to 2y, which is equal to minus 2x over y. Right? So what is the question? We need to find the value of x when x is equal to 12. But when x equals 12, also we need to know the value of y here, right? So since they are given by this equation, when x equals 12 squared, what is y? We can actually get the value of y from this equation. So from here, y squared equals 400 minus 144, that's equal to 256. That is y equals 16. It is possible, right? So now from here, dy dt, that is the rate of change of y with respect to t at x equals 12 is equal to minus 2 times, what is x? X equals 12, y equals 16, which is equal to minus 24 by 8.3 by 8.2 meter per second. Okay, that's just a unit. Right. Well, it is negative, as I see here, it is moving towards zero, right? It is decreasing. That's why it is negative. Okay. And why x is positive? Because it is getting moving away, it is increasing. That's why it is. That is one simple problem about related rates. As see here, we are talking about two things. The foot of the wall, the ladder is moving away, and also the top of the ladder, it is sliding down, right? These two rates are related to each other. So the whole actually this section is about this kind of problems. Another problem, it says that's filling a conical tank. Okay, water runs into a conical tank at the rate of 9 feet cubed per minute. So every minute, 9 feet cube of water is flowing into this container, right? Okay, the tank stands point down and has a height of 10 feet. Okay, here it is 10 feet. All right, and a base radius of 5 feet. So the base radius is 5 feet here, and the height of the cone is 10 feet. What is the question here? How fast is the water level rising when the water is 6 feet deep, right? And also in real life, actually, if you just uh, flowing or pouring water into this kind of container, right? As it actually goes up, the water level rises much, much slower. Why? At the bottom, right? Actually, the base radius is smaller. As you just move up, the radius is getting bigger. So that means that also volume is getting bigger. So actually the rise of the water level slows down. V2, is everything clear?
Yes, sir.
Good. Because sometimes ask me a question so that I feel that you are there, okay? Everybody's so quiet like a seawater or the lake, I don't know. Anyway, let's continue. So what is the question here? Now what is given here? It says that water runs into a conical tank at the rate of 9 feet cube, right? What is this actually? That means that the change of the volume of the water with respect to T. It is given here, it is 9 feet cube per minute. That's given, okay? And how do you find the volume of the water in the container, right? That means that what is the volume of the cone? We know that volume is equal to 1/3 times pi times r squared at any height, right? What is that radius of the circle? It is x. So here we have x squared times height, right? And what is the height? Let's say height is y, okay? Because at every moment it is changing, right? So what is the question here? What is the question here? How fast is the water level rising when the water is 6 feet deep? Now, as you see here, okay, that is our volume. Okay, this is our volume problem. But here, how many variables do we have here? V, it is changing. X, it is changing. Guy, who's that sound is coming from whom? Okay, whoever's ping is there, can you mute yourself, please? I cannot see that now. Can I see it here? Okay, so here, actually, if I just differentiate this, we can do this, but it will be complicated. But here the point is, can I just reduce the number of variables in this equation into two? Okay, so how can I do this? Actually, here, there's a relationship between this x and y, right? And if I just draw this triangle, it is something like this. Okay, it is something like this. Okay, that's the slant height, that's a base, it is 5, it's not changing. Height of the cone, it is 10. But at any point, let's say this one is x, and this height is, what is it, y. So the remaining part, it should be, the total height is 10, it should be 10 minus y. From the similarity triangles right here, we have x over 5, right? Opposite this angle, it is x5 is equal to opposite this angle. And the small one, right, is y over the big one, it is 10. So that means that here we need to find, what is it? How fast is the water level rising when the water is 6 feet deep, right? So water level is rising. That means that we need to find y. So I'm going to express y in terms of x. So what is y here? Y is 2x, okay? So that's how actually these two things are related to each other. Then in this equation, I will have that thing. It is, no. Actually, I need to express x in terms of y because we need to find dy dt, right? From here, x is equal to 1 over 2y. Okay, now if you substitute here, we have 1 over 3 times pi times what is x? It is 1 over 2y squared times y, which is equal to 1 over 4. So I have here 1 pi over 12 times pi cubed. Right? So now if I differentiate both sides with respect to t, what do we have here? Here we have dv dt. That is the rate of change of the volume of the water, right? On the right-hand side, pi over 12 is a constant number. Now I need to differentiate y with respect to t, right? It's just a composite function. Here we have 3 times y squared times dy dt. Okay. So it says that, what is it? uh, how fast is the water level rising, right? I know that actually dv dt, it is constant, right? Actually, it is 9 feet cube per minute, right? And also why, when actually, what is it? How fast is the water level rising? When the water is 6 feet deep. That means that y is equal to 3 when x is equal to 6, right? This is the depth of the water. I mean, not actually depth of the water, that is the radius of the top of the water, and this one is the depth of the water. When actually the radius is 6, the depth of the water is 3. So using this relationship, now we can calculate this. Let me just change the color here. So from here, what is dy dt? So dy dt is equal to, right? And this one is 3, 12, they cancel each other. Here we have 4, take to the left-hand side. So here we have, what is it? 4 over pi, right? Times, and here we have 1 over y squared times, here we have dv dt. Okay. What did I do here is just add everything to the left-hand side and just keep dy dt on one side of the equation. So now we need to calculate here dy dt, when, what is it? It's 6 feet deep, right? That means that when y is equal to 6. So that's equal to 4 over pi times 1 over 6 squared. So that is 36 times dv dt, that's equal to 9. So which is equal to 9 times 4 is 36, over 36 is equal to 1. So that's equal to 1 over pi. What is it? Is it given feet? So that is feet per minute. So that means that when actually the height of the water is 3, actually, what is it? The height of the water is changing at this rate, okay, at a single point.
Sir,
Yes.
how would we know H equals 6?
Okay, here in the question is saying that how fast is the water level, it's y, right, rising when the water is 6 feet deep, right?
Oh, I think when the water is 6 feet deep, it is the Y.
Yeah, it is y, right? So that means that when y is equal to 6, y is equal to 6. You are right. If y is equal to 6, so x is equal to 12. Okay, so even I don't have to find this x from here. So if it is 6, right? So it should be, okay, everything's correct. I think I just wrote wrong thing here. Is it correct now? Because y is equal to 6 here, y is equal to 6. Y is equal to 6, third 6. Okay? All right. Good. Thank you. So here
Sir,
y should be equal to 6.
X should be equal to 3, not 12.
Yes, because x is half of y. It is 3. Okay. Good. Anything else? All right, good. So let's move on then. Another similar question. How rapidly? How rapidly means how fast, right? Will the fluid level inside a vertical cylindrical tank drop if we pump the fluid out at the rate of 3,000 liters per minute? Okay, so here we are given some kind of cylindrical tank. The question is, how fast will the fluid level inside a vertical cylindrical tank drop, right? It is dropping this. So let's say at any moment, the height of the fluid inside the cylindrical tank is h. What is it? Let's say it is liters. Let's say it is in centimeters. Okay, let's say in centimeters. So every minute, that's it. So again, at any moment, what is the volume of the water, right, or fluid inside this? So the volume is equal to pi r squared times h. And here, as you see, r is constant. It's not changing with time, right? So just keep in mind that r is not changing. It is constant. So only what is changing here when height is changing and also volume is changing, right? And both volume and h, they are functions of t. So now if you differentiate both sides with respect to v, here we have dv dt is equal to pi r squared times dh dt, right? So from here it says that dv dt is changing, right? 3,000 liters per minute. So now we need to change liter into centimeter because this h actually we need to find in centimeter, right? So we know that 1 liter is equal to 1,000 centimeters cubed, right? So that means that 3,000 liters per minute means that here we have 3 times 10 to the power of 6 centimeters cubed per minute. Okay. Or it is minutes. It's a huge thing. The radius is r. Okay, let me just keep this in centimeter. Okay, because 3,000 per liter, I think, should we change this into meter? Anyway, let me just keep it. It's like it doesn't matter, okay, because unit's not asked here. So now from here, then what is dh dt? dh dt will be equal to dv dt times 1 over pi r squared, which is equal to, what is dv dt? dv dt is 3 times 10 to the power of 6 centimeter cube per minute, but it's minus, right? Because it's dropping. So here we have minus 3 times 10 to the power of 6 over, here we have pi r squared. So here it will be centimeters per minute. So that is the rate of change of, what is it? The height of the fluid in the container. It is minus because it is dropping, right? It is decreasing. That's why it is minus. And it depends on the radius. As you see here, If the radius is big, right, it will be, I mean, the rate of the change of the height will be small. If the radius is small, it will be so fast. Okay, let's move on. Another example, maybe the last example. In the afternoon, we will continue. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the lift-off points. So that is the ranger standing here. That's the lift-off point, right? At the moment, the rangefinder's elevation angle is pi over 4, the angle increasing at the rate of 0.14 radian per minute. How fast is the balloon rising at that moment? Okay. So again, after a certain time, right? Actually, the rangefinder is standing here, right? This guy is standing here and just flying or just watching whatever it is, the balloon, right? And it's just moving away but rising up. Anyway, he's just watching from this point. And here we have two things, right? The horizontal distance from the lift off point of this balloon, right? And after that, the height of the balloon and the distance between rangefinder and this. Okay. From here, how can we connect this? Because the question is, how fast is the balloon rising? How fast the balloon rising is if we denote the height by y, so we need to find dy dt. But when it stays at that moment means when the angle is equal to, that theta is equal to pi over 4. Okay. And also what is given here, the angle is increasing at the rate of this, right? So the angle is, that means that the theta, the t, right, that is 0.14 radian per minute. Now from here, how can I connect theta with y? Just using tangent function, right? What is tangent function? Tangent of theta is equal to y over 500, right, feet. So now from here, what is it? Y is equal to 500 times tangent of theta. So we need to find dy theta when theta is equal to pi over 4. Now from here, if you differentiate both sides, theta is a function of t, right? So here we have dy dt is equal to, on the right hand side, we have 500, right? What is the derivative of tangent with respect to theta? That's equal to secant square root of theta times. Now theta is a function of t, so here we have d theta dt. So the question is, we need to find dy dt, right, when theta is equal to pi over 4, which is equal to 500 times secant square root of theta, secant square root of pi over 4 times dt theta is given, it is 0.14, that's equal to 0.14, which is equal to 500 times, actually 0.14, that's equal to 5 times 14, that's equal to 70. Sorry, it is 17, right? And secant of pi over 4, secant means 1 over cosine, and that is 1 over square root of 2, that is square root of 2 squared, that's equal to, what is it? 2, which is equal to 140 feet per minute. Okay, so at that instance, actually the air balloon is rising at the rate of 140 feet per minute. Okay, ladies and gentlemen, do you have any questions? All right. We have 6 minutes left. Okay, that much is enough. We will continue in the afternoon. Okay. So if I start, I cannot finish this. See you in the afternoon. Enjoy your lunch. Bye-bye.